plus there. So we started with OF at 10, OF at 10 plus, and plus. Okay, so our equipment getting more and more and more. Okay, so then this time we get another box coming in with this specification inside. Okay, basically there's this RTX 3080 inside there. Okay, so our side we try to support in terms of installations, the whole entire network and so on. We are connected to MyRAN, Malaysia Research and Education Network. MyRAN, they actually give us a very full support. For the network in my university, we fully operate our own. Okay, they give us a set of IP. So when we are requested to give one public IP, we can immediately give you. No need to go through anybody else, right? Whether you want firewall, you don't want firewall, please take care of yourself. Okay, now what you can see that is we divided the network into a few segments. Basically, we have the management and control segment. Then we have the data segments. Okay, a lot of data actually running through behind here. Okay, so one of your servers is inside here. Now, besides MyRAN network is MyRAN network. Then we have our university networks. Okay, university networks go to the internet is through the commodity networks. Our network is the research network. It's using the research. Now, so what happened will be in case of certain things happening, like sometimes some of you kill yourself. If you understand what I'm talking about, you try to configure something onto the box, right? The next thing you kill yourself. Then I'm not able to access remotely. You are also not able to access remotely. So what we did was we can now go through the network using VPN. Then we get to another interface. But if you kill that interface, it means gone. Thank you very much. Okay. So sometimes if those who configure, you go in, you will see, hey, how come there are some funny IP addresses on certain interfaces? So that are what we are doing here. Okay, now next, we did this on the wired to focus. Now, actually, I want to discuss more on this rather than some other things. So I just want to show you this diagram first. At the very beginning, we were thinking about how to get the traffic data. MyRAN is very specific to us. Whatever we use, we can't generate sufficient data to do predicting, to do forecasting, whatever is impossible. Now, and the worst part, it is a point-to-point. If I'm going out from MyRAN, I have no other way to go. I cannot say that, now because of this network is quite congested, I can route to the other network. I'm so sorry, I don't have that capability, and I don't have another network to go through. Okay, so we start to have a lot of problems. Now, what we did was we actually downloaded data set, huge data set coming down. Now, the next thing is how to implement into your network. So at the very beginning, we thought of, okay, let's simulate the environments, put up many nodes with all the OVS, all kinds of things, and then start to follow the patterns to actually pump data. Then we have a big problem. So what are we trying to focus? You are trying to focus per IP, per router, per gateway, per link. If you understand what I'm trying to tell you, you don't know what you are going to focus. And if you start to try to focus everything, I'm sorry, it will take days, right? So then we realized, let's go back to the very original. We may have only two paths from source to destinations. Then slowly you can build a third path inside there. Okay. So now, if you start to see this thing, you can see that these are the real value, are the green color one, correct? So what we did was, we have primary path and the secondary path. Then what happened here? We start to do this side, original data, used for training purposes, do prediction over here. Okay, so we try to use different type of predictions. We try to get as close as possible our prediction. Now, this is the actual, green color is the actual data. But in the real experiment, the green color data are not being actually, because at this point, you want to join me? I'm a lecturer. I will get mad. Okay, understand this. Those they do. Okay, at this point, you don't really know what is happening next. Although now you can see there is a green color, correct? But when you really do the prediction, you must act like you don't know. Right? So we start to do the prediction. The prediction is something like this. Right? Now, so you see, here it passed through a 60% threshold. Now, then your next thing, why 60? 50 cannot. 70 cannot. Can you put a threshold at 80 or not? Can. Why cannot? Then there is a possibility. You got the primary and secondary. You put the threshold at 80. You realize that one link will actually shoot up to 80. Another link may be empty. If this is your objective, go ahead. If your objective is to have a more distributed environment, then you actually lower your threshold so that some of the traffic will go to the second link, correct? So when both of them actually hit the threshold, you use some fuzzy logic to actually push up the threshold. Then, you see, to push the threshold itself is actually a lot of research can be done over there. So what we did was, now, we know in our prediction, we know something is going to happen here. So we start to do rerouting at this point. Of course, you don't, after you hit the threshold, you start to do rerouting, right? You predict that after a few seconds later, there will be a traffic coming up. So I start to do rerouting. So you start to see this. So you see, originally, the traffic is coming down here. But because you route the traffic from this side, your this side traffic is going up. Now, the threshold is at 50. This side is coming down. So you try to balance the environments. To say it's very simple, actual running is very complicated. Okay? I just want to share with you something like this. So you see what we are trying to do there. Okay? Now, the difficulty will increase double and double if you have extra link. Extra another link, extra another backup link, and so on. So the possibility will be much difficult. It depends on what you are trying to do. Okay, so of course, then we have some, when we get the data set down, sometimes there will be some data missing. You don't know what to do. If you simply use 0 to represent that, you will get a totally different graph for your prediction, right? So you try to go and figure out what should be the missing value, or you put a missing value there, it won't, the data will not get you into troubles and so on, okay? And will not affect your prediction and so on. So there are some methods we use inside there, okay? So that's one. Now then, today, morning, we talk about all the fuzziness. So basically, this is the most important graph. You can, it's the behavior of the Wi-Fi, that if you have two AP here, if a few stations join the first AP, subsequently, most of the station will also join the first AP. You ask why? Don't know. They have all the beacons things, you know, because there are more transmission going over there. So you start to see different patterns of how the machines associated to the AP. So then you start to see that there are machines that you're connected, but you can't really actually send, or your throughput is very low in that sense. Okay, so today morning, Sue presented how we actually push away, okay, de-associate some of them and push to the other machine. Of course, during the process, we encounter a lot of problems. Flipping. I push out, the other side also push out. So they don't, so you start to have a hold down timer, all these kind of things going on inside the system. So this was what happened there. Okay, don't worry, I will. Let me know. What is the time now? 10 more minutes. Okay. Now the next one is we did is network automations. Okay, why we need to do this? I will. Okay. This is what I want to show you. Now, as I told you, we have our OF at TEIN projects many years already. We have nodes in, say, Bhutan, Myanmar, Vietnam, Thailand, Laos, Indonesia, and so on. So we have all the nodes scattering around. Okay. What Afat did show today morning was you have the connectivity in between Korea, Malaysia, Pakistan, and Cambodia. Right? We have huge environment. Now, if we don't do network automation, sorry, we die. Okay. Now, so we think of what we should do with it. Then at the end, we decided to use the Kubernetes. Okay, so the master is in then all the site become so-called like the nodes or the slave, things like this. Okay, now, then we automate BGP, all the BGP to run at all the nodes outside there. Okay, then with all the data coming in. So what happened was we can use this for training purposes. We can use this to run for students to understand how the whole network actually runs. So we use this for a training. The students 1, students 2, and can be student N. It depends on how many students want to join in. During the training, we have around 18 students. Now, this is the student own internal network. What does it mean? The student use GNS3. Put in all the routers. Set up a OSPF network. One of the node become gateway. Right? So, but our node for them to become a gateway is we provide them with a virtual machines. Okay? FRR running there. In between this, we automate the tunnel process. So these machines and our machines, they can choose. They want to actually dial in or make a VPN into or they go to their local environments. But we encounter one serious problem. Say in Myanmar, the Myanmar student from home, they want to dial into our node in Myanmar. Actually, the traffic went down to Singapore and returned going back because locally their RAN are not connected to their the actual network. So actually, since you are doing that, you better connect to correct? You just go to Malaysia and it's done. So this is done. So these are all automated. And what we did was, we actually pump the real BGP data from on top and share down. At the very first try, we've forgotten that the total BGP routes are 900,000. Do you know this? The total BGP routes at the backbones are 900,000 plus routes. So at the very beginning, the students will get something like 300 routes. Everybody become very excited. The next thing, nothing happened. The next thing, their PC crash. Because there will be 900,000 routes coming down to your routers, So then we have to do it like we limit to something like 100 routes plus the default routes, this kind of thing. Okay, and do network address translation and so on for them to actually access. So that is what we are doing for our network automations. It's very complicated. You need to know a lot of programmings. You need to learn about YARN models. You need to learn about net config, REST config, or Ansible. It depends on what you are trying to do. Now, after this, what we are going to do is to monitor the network using the same methods and do the intent-based routing using the policy to actually write onto the routers so the traffic can follow the path that we want. Okay, thank you very much. Any question?
Thank you so much, Professor. It was a quite nice talk. My question is just about the data set. You were saying that there were some missing values. So there are some techniques to replace the value. I was eager to ask that whether you replace the value with the mean of the whole data set.
Yeah, a few.
Oh, yes.
Yeah. Okay.
Thank you.
The purpose of putting this value is not to get a correct value, is to get a value that will minimize affecting your other value. You know, you cannot just put a zero. Put a zero, suddenly the whole thing prediction will goes wrong. You need anything?
Is there any question? Okay, thank you, Professor Ling, for your very informative presentation. Our next presentation is from NUST. Dr. Qazi Mazharul Haq from NUST will present the IBN status and implementation of GNN on their part. So it's online? Yeah, it's online.
Hello, Dr. Afaq, can you hear me?
Yes, we can hear you. Can you please share your slides?
Okay, let me share my slides. Can you see my slides now?
Yes, can you go to the full screen mode slideshow?
Okay. Now
Yes.
can you see?
Yes,
okay.
yes. You can start.
Okay, so hello everyone. My name is Dr. Qazi Mazharul Haq, and I'm one of the team member at NUST Node. And today's presentation, I'm going to present about the status of IBN 10 at NUST and the graph neural networks for path estimation. So the team at NUST consists of Dr. Ehtishamul Islam, who is a co-PI in this project, and I'm one of the team member, Dr. Qazi Mazharul Haq. And we have two students, Engineer Muhammad Hamad and Engineer Anam Fatma. Now the whole IBN 10 project partners are Jeju University, ITC Cambodia, Sarhad University, PAN Pakistan, and University of Manaya. And NUST is one of the partner in this whole project. The whole architecture of this project is previously presented by Dr. Afaq and explained by Dr. Suleiman, is consists of multiple nodes, and the apps are already installed and deployed on these nodes, and these nodes are already connected with each other and can communicate with each other instances, and they're also connected with through SDN. And after the data is collected by all these apps, we can use machine learning to find an optimal path. So in the next slide, I will discuss about what is the current status of the project deployment at NUST side. So till now, we received our equipment in January 2023, and we were trying to deploy it in our institution, but due to some administrative rules and policies, firstly we deployed it, but the IP was given a local IP, then it was not connected to the other nodes. Then we did some, got some permissions from our institution, and now we have a public IP, which is here, and we have subnet mask this, and the internet is provided by PAN Pakistan, PAN ECC Pakistan with a 20 Mbps connection. And we at NUST also helped NCC with the procurement equipment of 3 other sites in Pakistan. Currently, the whole equipment is already deployed at NUST side, and multiple services are hosted at NUST side. And we see that for monitoring data, we first follow some applications, web pages, and videos for the traffic flow on our NUST side. And the data is monitored through perf sonar and OVS exporter tools. These exporter tools are connected to the to check the VM performance. All the nodes are connected through the overlay network that can share the services with each other, but with multiple paths. So after the collection of data, we are using an ML or maybe AI machine learning models to find a suitable or optimal path between these. So this is the current status at NUST side. And apart from that, now we are proposing to find some machine learning models to train and to find the optimal path. Till now, we have proposed the graph neural networks. As we see that machine learning consists of many models, CNN models and LSTMs. Somehow for time series data, we see that LSTMs can work properly, but since our data is consist of networking data, so we are proposing here the graph neural networks, and we are preparing our data according to the graph neural network. In this slide, I'm going to explain what would be the input to the graph neural network model. And so the input data will consist of topology and traffic matrix and the routing scheme that we will give to the input model. The input model should consist of graph neural network, and we can find the performance metrics based on delays or jitter. So it depends on our objective if we are going to find the per part delay performance of the network or we can find the jitter. The whole data set, the input features of the data set consist of the network topology, the configuration, and the traffic matrix. So till now, according to our literature review, we found that there is a RootNet model that is already trained and publicly available for testing and for training. And we are going to choose open source dataset to train on this RootNet dataset. This RootNet dataset can take the topology, traffic, and the routing as an input. And after training, it can generalize in unseen topologies and routing configuration and traffic. So for now, the conclusion is that I discussed the status of the IBN 10 at NUST. And in the future, we are going to implement the graph neural networks that are going to be trained on the open source dataset. And after taking the data from Jeju University and the whole data set, we can train on the same network we will train on the IBN 10 data set. So this is all about my presentation.
Okay, thank you, Dr. Kazi, for your nice presentation. So are there any questions from the audience? Okay, Dr. Kazi, just before coming to APAN55, we actually achieved some promising results using GNN. So
Okay.
we will share the results with you so that
Okay.
we can collaborate further on the findings that we have got. So thank you very much once again.
Sure.
Thank you.
Thank you.
Okay, so our next presentation is also online. It's Mr. Fawad Raza from PERN, and the title of his presentation is Status of IBN at PERN. So Mr. Fawad Raza, can you hear me?
Yes, I can hear you.
Okay.
Can you hear me?
Yes, can you please share your slides?
Dr. Kasi, can you unshare your slides, please?
Wait. Okay.
You can see my presentation?
Yes, we can.
Okay. Hello, I'm Fawad Raza from PERN. So this is a little short updates on the PERN, the IBN at TEIN deployment at PERN. So the updates are very similar to the NUST that has been presented just before. So going through the contents, we have system architecture, PERN node activities, and architecture of monitoring modules, monitoring tools, and IBN TEIN workshop that has held in PERN. So this has been discussed in the morning also, and in the last presentation also, that this is the overall architecture of the IBN, where the PERN IBN application is basically deploy the OpenStack cloud, and after the OpenStack cloud, it builds the GNN tunnel, which can be seen on the SGN controller. The monitoring tools that monitors the bandwidth, delay, and jitters on all that, and also the performance of also the utilization of the virtual machines are being given to the input of the machine learning model that has been presented in the last slide. and that is that used as an input in the for the intent-based application. So this is the overall architecture, and it is the closed loop architecture where it clears a cloud node it deploys the node cloud on the node, then it creates the kernel, and then it will the kernel, as I said, that it will be viewed on the SDN controller, and by submitting the intent and the input of the GNN model, it finds the best deploy the best path, and the intent is showed on the deploying the best path on that for that particular service or a particular intent. So description on the on site, basically the undersigned is basically I'm the site manager of the PAN project, PAN node deployment. Basically the OpenStack cloud has been deployed at the PAN node, and video as a service has been deployed, which has this different kind of resolution like 720p and HD. Also, the HDL service can also be hosted on that PAN node. Virtual switch is basically controlled by the SDN controller, and also the routing and switching also managed by the SDN controller. And above that, the overhead network has been built on these on the cloud nodes. These hosted on the cloud can then share their host services with one another using the overlay network. The communication can take several paths using the ML model. So the ML model are trained on the data obtained by the monitoring tools at each node, including PAN, NAS, and Sarhad University. The monitoring node tools also deployed at PAN for traffic. Like the monitoring tool we have used in this project is basically the perf sonar, and also the Open Virtual Switch exporter. Also, we have a node exporter at each VM of the cloud to monitor VM performance. This is the specification of the PAN node that has been delivered under this project. We have 3080 processor, GPU processor with 10 GB. The RAM is also the 64 GB RAM. So this is the specification of the PAN node, node that is delivered in the project. This is the pictorial view of the physical deployment of the PAN node in the data center. It's basically deploying the old data center of this PAN data center. All the activities has been done, and the tunnel is established, and services has been stored in the PAN node, and the cloud has also been working. And this is the current IP address of this PAN node. Now again the architecture is same. Basically, this PAN nodes, the perf sonar monitors takes the information regarding the delay and all, monitors the information regarding the delay, jitters, and all that. And also it gives you the PySpark for the PySpark, and then it gives you input to the Prometheus, a time series database. And this time series database stores the information, and that will goes to the machine learning model. So this is how the PAN sonar installation has been done on the. This is a Ubuntu based operating system is used, and this is how the PAN sonar installation is done. Then the Prometheus. This is how the Prometheus has stored the data. And this is how the IBN portal and different node sites has been active. OpenStack Cloud has been active on the different node countries, including PAN. The second activity that has PAN executed in this project is basically it holds the workshop, IBN TEIN workshop in 10 to 12 January. It's been attended by the PI of the project, Dr. Wang. And all the co-PI is Sarhad University and NUST. And the local participants also joined from the NUST University, Sarhad, and all university. Basically, this is about a 3-day workshop, and the topics related to IBN has been presented in this workshop. Most of the possible participants from the Cambodia, Malaysia, and all other countries were also joined, but through the virtual mode. So that was a picture of the workshop, and then Thank you. Any questions?
Thank you, Mr. Fawad, for your presentation. So are there any questions? Okay, Mr. Fawad, as you know that we have successfully deployed the nodes at different sites in our project, and now we can see the tunnel between Korean and Jeju National University and as well as with PERN. So I think we have to collect the actual data from now on, and we will apply that data to our machine learning models, that is GNN in our project. So I hope we can work in this direction. Okay, thank you once again. Okay, the next presentation is from ITC Cambodia. Dr. Sang will present the status of IBN in their site and their utilizations. So can you please come, Dr. Sang? Yeah, we'll play the presentation. इधर रखेंगे Right.
Thank you. Good afternoon, everybody. My name is Sokchanda Sreng. I'm a co-PI of the project IBN at TEIN, which have 3 countries together to work together. I don't have many slides to present because we just start the implement, so we don't start the experiment yet from my side. Yes. Yes, I will present a little bit about team member and status at ITC and future experiment that will using IBN TEIN. For my team, myself, co-PI, and Dr. Pajratana, researcher, and I have 2 PhD students who will deploy the network, and 1 master student, yes, and another one is technical support. Sorry. The project started from March 2022 and ending in June 2023, right? If I don't confuse. And normally we have online meeting together with our member. And we received the equipment, yes, received in October 2022. And we have some problem because of something like the administrative process. Even we ask for IP, public IP from the university, still takes some time. Yes. Anyway, yes. And the future experiment with the internet ITC, my student will use it. Same as the first one, the intern, we work on investigation when a configuration and deployment issue. Yes, often network, but it doesn't work. So maybe we start think about using IBM network. And the student, they work on deploying application. Yes, I think he did the presentation during the workshop in Pakistan. He did the presentation online. Yes. Maybe the third application my colleague Dr. Pajratana, he will use the IBN for the deployment of the platform. Yes. I think that's all. I don't have anything more to talk. Yes, thank you very much.
Thank you, Dr. Sang. Yeah, for presentation. Okay, thank you. So our next presentation is from Javier Diaz Rivera from Jeju National University. He is a PG student at Jeju National University, and he will present IBN and blockchain-powered zero trust and zero touch solution.
Thank you, Doctor. So I think I can just start it directly from here, right? Correct? Perfect. So this presentation is going to be a little bit different to what we have been seeing with the previous presenters. This is not actually an IBN TEIN project, but it has many relationships to it. The name of the presentation is CT&T. It's intent-based networking and blockchain-powered zero trust and touch solution. And this is a project that we have been working for the past year in our lab. And basically, we know like what is the nightmare for every IT administrator or network engineer, right? Like a network security. It's very important. And administering security itself also has become very hard with every new technology that we have right now. So there is this question that is the castle and moat model sufficient in a sense that is it enough just by strengthening the outside, right? The verification for having access to inside resources. Is it enough? Is the perimeter trusted by default? Then that means that whatever is happening inside here, it goes, right? I mean, it will be allowed. So one problem that we're having right now, and then we may have seen also with the presentations that we have before, networks are distributed. And what is the perimeter right now in the current networks, especially when we are talking about overlay networks themselves? So we cannot geographically define some sort of perimeter that can accommodate to every type of authentication or access control that we want to have. We have heterogeneous networks. We have also different geographical locations and distribution, different type of services also, and different type of users that want to access these type of services. So the motivation of our research comes from the terminology of zero trust networking. We want to achieve a multi-layer security that can provide authentication, authorization, and granular access control. And everything revolves around a single thing that is called identity. Having a strong identity to identify not only the end users or the services, but also the equipments or anything that is providing some sort of service inside of the network itself, that there may be also routing services, there may be controller services, stuff like this. So in order to achieve this and to reach this motto that never trust, always verify, we are thinking about these layers as permissioning, enrollment, service policies, and session tokens. So we have considered something very attractive in the sense of the technology itself, including blockchain in all of these layers. So why? Because in the CT&T system that we are envisioning, we have a secure network overlay where we can have a server or a service provider that it is deploying or implementing any type of service that you want to give it to a user regardless of what is happening inside. You don't care about those kind of things. But you want to give them to the right users, the users that are allowed to access this service only. So in the same concept of IBN, we have a higher layer of definition of these policies, right? We not only let you access the service, I mean, we not only let you have these end-to-end connections, but also will enforce the rules for access control, for authentication, for authorizations themselves. And everything is happening through the communication of the blockchain. And we have already standard ways for achieving authentication, authorization. What we are doing is that we are encapsulating these standard ways
for example, OAuth with the JWT tokens, instead of using just the standard JWT tokens themselves, or standard session tokens for managing these end-to-end connections, we encapsulated into non-fungible tokens that are the most commonly known as NFTs that will give you this proof of ownership because we're managing unique identities that are related to the blockchain themselves. So whatever is transmitted or it's acquired by an end user or an end server itself can be verified and trusted by the automatic mechanism of control that the blockchain has. So exactly why the use of the blockchain itself, I just mentioned it before, because of the unique identities that are able to be generated. Blockchain itself, it works on the concept of private keys, public keys, and in some other type of blockchains like the Ethereum blockchain with the public address themselves. Those blockchains are highly configurable. They can be used also for private type of networks. So in this sense, it can be used to provide permissioning. We will be granting access only to verifiable accounts. And as I mentioned before, encapsulating these JWT tokens or session tokens that are standardly used into the NFTs themselves. This proof of ownership is being provided by the blockchain itself. You don't need to have like a certificate authorities. You don't need to have a PKI for providing this centralized or centralized trust, however you want to do it, because the blockchain is internally doing this verification by itself. And the programmability. This thing is very important. In order for dedicate or having some sort of managing high-level management with the IBN, we need to have a configuration that can be done on real time. So this thing is being provided by the smart contracts themselves that most modern blockchains they allow. So basically, we're using the blockchain because it provides keys that we can get from any type of encryption algorithms. But most of the time, these keys by themselves, they don't mean anything, right? They need to be managed or they need to be verified by something. And that's why, like big enterprise, they pay a lot of money for some certificate authorities or some other enterprises that have the capability for providing trust to somebody. They are very specific. So they are very specific to case-by-case scenario. In the case of blockchain themselves, you can have a configuration that is going to be managed by the centralized system that can also be redundant in a case of if the blockchain is big enough, like a case of some nodes go down or something like this, the operation should not be hampered. So of the smart contracts, we can have logic that can help us, that can help intent-based networking, define roles, define services, define service policies that also will be safe inside of the blockchain themselves, and will have the same capability of immutability that can grant that the configuration that is being done into the overlay itself is being trustable, is being done by some agents that have been created by the blockchain itself. So everything that goes to the overlay can be immediately verified. Also, because blockchain and standard networking are totally different in the sense that how they operate. There needs to be a way for guaranteeing that this information that is being created into the blockchain can permeate into the lower layers of the network itself. So we're achieving this through blockchain event and automatic synchronization that keeps information that we call on-chain information and off-chain information synchronized. Also, the multiple layer that it has, the blockchain itself provides the single source of trust that is required in order to have this type of systems. So Content-based networking type of functionality, we have a higher layer of definition of type of roles, identities, type of services, in the same fashion that we just want to give some abstraction of what to provide inside of the network itself. And the main difference into other projects that we have been doing is that instead of writing everything directly into the database, we are using the blockchain for it. The blockchain not necessarily is used for storing all the data of the IBN itself, but just the most sensible data that needs verification. And it's the most sensible data that should never change, in a sense that it should not be changed indirectly. It should always follow the authorization or authentication flows. And also, this information is not understood by the network itself. There needs to be some sort of translation, right? That can use the information that is being put into the blockchain and translate it into configurations that can go into an overlay network themselves. So we can map some type of services, map these policies into actual configuration that needs to be automatically being input into the network itself. So we have that on the concept of session tokens also. The creation of service policies that are encapsulated into the session tokens themselves are transmitted to either clients or either service provider, depending on the type of end-to-end service or end-to-end connection that wants to be established. And also for our own work, we have used an open source project that is called OpenCity for the actual overlay network management that we have. Because we are mostly focused on the development on the blockchain side of things and the higher layer of that is the IBN integration with the blockchain. So practically this is the whole system that we have. As you can see, the network and how it's been created is something that is called like a software-defined perimeter. A software-defined perimeter is very akin to software-defined networking. But we have a controller, we have routers. But point of view of security itself. Instead of just thinking about the networking of end-to-end connections, so transmitting data from one point to another, they are focusing more on authentication, authorization, how to grant access to something. So this layer centers on blockchain operations themselves. But of course, in order to integrate these different types of technologies, what will require the configuration of and the development of APIs that can communicate with agents that run in clients, agents that run in providers, and it is like configurable. It is stored through smart contracts inside of the blockchain itself. And these smart contracts themselves are managed by the IBN system. The configuration that exists inside of here, that goes inside of the overlay itself, goes through the SDP controller, and the SDP controller just input the rules into routers, and the system itself verifies that all the information that it's been flowing inside of the network matches the information that has been coded inside of the smart contracts. That the smart contracts have like a coded inside of the blockchain themselves. So basically, for the identity, we are using the Ethereum blockchain itself for the whole project. And for the identity, we are using the Ethereum keys that are the private keys, the public keys, and also the Ethereum address. So the Ethereum public address basically is the identifier for either clients or either providers in our network. And of course, that we are using a blockchain, we cannot just allow any client that has a public address. We have a process that There is a multi-factor authentication to assert identity or to assert credentials of a user. And after that, the user itself is permitted into the network, into the blockchain itself. Without this process, even if a user can direct or physically connect to the blockchain through a IP or through a port, the blockchain don't listen to anything like that. So there is another process that is called permissioning that should allow endpoints to a node. Also, as I explained before, because we are following the standard ways for reaching authentication and authorization, is that we are encapsulating the tokens or JWTs as NFTs. These NFTs are associated to metadata that includes the ownership of the token, plus the public address of the entity that used this token itself. Because one of the other issues that these tokens may have is that if there is a third party or a man-in-the-middle attack, essentially that can sniff your network and can get a token like this. Because what the token is going to be used for, so just grab it and use it. The authentication servers, they don't care who comes the request, they only verify that the token is valid or not. In this case, it's impossible for somebody to sniff the token itself, because once the token is encrypted using the same private and public keys, so the data is unusable. Even if you help to the token itself, it doesn't come by a normal authentication or authorization server, it comes by the blockchain. So the blockchain needs to actually verify that the request is coming from somebody that has been permissioned into the network. So basically, what we are doing is that if we are going to code, or if we are going to define the smart contracts that are going to be used for the policy management, what we do is to define the roles. These roles are typically what somebody can do inside of the network itself. We can also define, for example, the type of identities and how they are assigned to the roles themselves. And everything is done through the blockchain, but by the use of the IBN manager. And also, for example, the type of services that we're going to have in our network itself. And this with some configurations that we need to know. Because we're using the OpenCD as the overlay itself. We're calling domain and ports. They are only relevant to the, but they are not relevant to an actual connection itself. Even if you put an IP address, this IP address is completely isolated to external access. It can only be accessed through the same flow that requires authentication, authorization, and access control that is granted by the blockchain itself. And of course, you need to have the actual roles or the actual definition of the service policy to access this service. So then what we have is like a policy record that let us know that there is going to be a resource that is going to be advertised in the network itself. For example, a video is going to be someone that has access to this resource that is a role. So as we know, the roles are assigned to an identity, and there is also going to be someone that is going to provide this service. That is the service provider itself. As I mentioned before, every entity in our system has a public address. So that is the way that the blockchain knows that everything is working as it should, that every entity that is like this configured in our network, it's a zero trust and touch system. As I mentioned, the blockchain itself doesn't communicate directly with the network. This is done through configuration and synchronizers that get the on-chain data and replicate it into the overlay itself. And also there's a verification that happens automatically that keeps this information synchronized. It is a validation of we have the blockchain as the single source of truth. The configuration that exists in the blockchain is the configuration that exists in the overlay. So that's this configuration has to change. No. So we managed to cut the overlay itself in terms of configurations indirectly. Synchronization itself of configuration, sorry, and will automatically always apply the latest configuration that was committed by the IBN system into the blockchain. As I mentioned before, the end-to-end connections, they work on the basis of session tokens, and these session tokens are also considered NFTs. So even clients and providers, they will require a token for the communication for a service, right? That one they want to advertise or they want to consume. And this thing is completely verified by the system itself. So there is a verification that may check that if this session token is expired or not, or if the session token is valid or not, in the sense that every session token abstracts some information of a service policy. So they are directly mapped or directly linked to themselves. So the information of a token that a client is presenting should exist in the blockchain itself. So these verifications are automatically being like triggered by the zero trust and touch system. And of course, if verifications are granted, the end-to-end connection happens. In the end, what we have is a system that has all of these components that is centered on the blockchain smart contracts for providing the identity management, policy management, OTT, and session tokens. But as I mentioned before, the blockchain by itself cannot interact with anything. So it requires some mechanism for having control of what is being inputted into the blockchain and how to map all of these configurations into the overlay itself and how to oversee that this configuration has been properly implemented. So this is the IBM backend. And we also have agents that should run on clients or services in order to communicate with the network. And because we are working with the OpenCD open source platform, the actual OpenCD itself, they don't have any functionality related to the blockchain. So we had to do some modifications for it in order to include blockchain itself. The main difference is that the OpenCD, they rely directly on certificate authorities for doing all this verification of authentications and the JWT tokens or the session tokens themselves. We scratch over all of that and we put the blockchain to handle all of these verifications themselves. And also we have a real-time monitoring system that lets us know the actual operation of the network, what is happening inside. And the IBN manager, that is a key that provides access to, we want to input roles, we want to input identities, we want to input service policies, and everything is abstracted into the configuration that should go in for the overlay themselves. So basically, this is like a standard flow of something that is going to be interacting with our network. The agents for clients or services, they are active. They have their own functionality. The IBM manager also have its own functionality. As a standard way of how services are provided, usually like a virtual machine spawns up and there is a service that goes inside of there. But because there is already an identity and there is already an agent that is tied to this type of services, well, if there is a policy, they will be allowed into the network. And the consumption of the network comes from fake domains. They are domains that they are only relevant to the service itself. So we can configure as many domains as we want for our services. They are unrelated. They are not accessed from outside of the overlay itself. So we can guarantee that the services stay dark. And also can monitor what is happening if we have the right credentials or the right policies for seeing what the traffic is inside of the network. Basically, right now, the CT&T system or the IBN administration has the access to monitor this data. If you want to take just a photo of this thing, there is a live demonstration that I have in a video. You can watch it later when you have more time. So I will just leave it there. So if you want to take a picture, here are just some considerations before I finish. Of course, I mean, we know that blockchain is something new, and there are some like implications specifically about the performance of the network itself. As we are using a permissioned blockchain, we can configure the block time and we can reduce it as much as we want. But of course, depending on the scale of the network itself, we need to find the most optimal block time in order to guarantee that when the blockchain operates, the synchronization of the information goes through all the nodes and is validated by the nodes that should validate that everything that is being input is correctly. And also, because we are not only using the blockchain, we are also using a secure network overlay. Parts are being like considering the network security per se, plus the authentication, authorization, and access control that I have defined. Also, another question is, can we trust the blockchain itself? Well, it depends. Most of hackings or things that have happened, they are not happening because somebody has cracked into the blockchain and destroyed something. It's because somebody may have stolen some private key, social engineering, something like this, direct access to the machine that may have these keys. So yes, there are some implications that we need to consider. And also because our project relies on permissioned blockchain, it depends on the business rules of the organization that will set up the overlay itself. How strong you want to have, how strong multi-factor authentication you want to have in order to define who is going to be a trustable employee. So it depends on the business organization. The system itself will be as strong as your weakest link. So in this case, it's like if somebody will give this private key to somebody else, and yes, right, you cannot do anything about it, right? But well, that is, I guess, is something that is not only particular to the blockchain itself. The focus that we are having right now is on verifiable identities. So because this is the native manner of how the blockchain operates, I think this is some advantage that it may have to actual implementation where we don't need to have a strict public key infrastructure, right? So we may have some emergent technology that can give us this type of verification capabilities. So basically that is it. This is the presentation that I wanted to give, and this is all. Thank you very much.
Thank you, Javier, for your detailed presentation. Are there any questions from the audience? Yeah, okay.
I have a question. Are you using the private blockchain or public blockchain in this system?
I'm using blockchain.
Uh,
blockchain.
Public or private?
Ethereum.
Ethereum. And then my second question is like, did you try to verify the transaction, right, or over the blockchain, right? What is the like performance of that? How long does it take if you want to put the authentic?
The block time. But we have done experiments with the standard block time of the Ethereum that is around 13 to 14 seconds, no issues. But we have gone as low as 2 seconds and no issues. So it depends on how low you want to go. And as I mentioned before, it depends on how distributed are your nodes. So for example, if you have nodes that are like in networks that may have high latency, then if you go down with the block time, you may incur in like problems of synchronization. So that thing is not be your own solution. But if you have, for example, a data center that you will have your blockchain distributed, but in a control environment where you have links with very low latency, so you may be able to go down very, very, very low. And as you mentioned, I mean, the blockchain itself is Ethereum, but it's not a public Ethereum. It's a private permission Ethereum based on Hyperledger Besu project. So it's very configurable. So it can be configurable to different type of scenarios also. No problem.
Yeah, I have the question about the synchronization mechanism that you do after the configuration has been passed from blockchain to the overlay network. Yeah, over here. So you mentioned that in case it is corrupted, you will check it again and then take the configuration again to do it, right? Yeah, the last one. So how long are you going to do this? So if the attacker can keep doing it, you're just going to keep synchronize. So that means that if it keeps happening, the network or the node will never come up, right? Or
in theory, once this attack happens, or if it reaches to happen, I mean, the first thing is that you will try to remediate, right? Like try to isolate the malicious node in this case. But as the configuration of the blockchain itself right now only pertains to service policies, identities, roles itself, the node can be caught or can be isolated or can be extracted from the overlay itself, and the up-to-date information can still be flowing because one of these nodes, unless it was the controller, won't like how do you say, like won't affect the overlay, the overall connection of the network itself. Of course, if the controller was the one that was causing this issue, then that thing will be a bigger thing because the controller is the one that oversees the whole overlay itself. But this thing is happening constantly, and also it's based on blockchain events. So the blockchains, they have something very similar to what the concept of a database, right? The transaction is committed, and once it's committed, it becomes immutable, correct? So once is committed, an event is triggered, and this event, the information of the event is not the important thing. It's just like it was triggered, then the verification happens with the actual information that is in the blockchain. So that's how this synchronization happens. No problem.
is there any other question from the audience? Okay, Javier, thank you once again. Yeah, thank you. Okay, our next presentation is from Muhammad Amar Hassan, who is a PhD student at Jeju National University, and he'll present next generation real-driven networks. So Amar, can you please come?
Hello everyone. My name is Ammar, and I'm PhD student at Jeju National University. I'm going to present about this next generation DRL driven network, which is actually a software defined networks, and we take advantage of deep reinforcement learning to optimize the policy enforcement on the network. So about the introduction, as you know about the implementation of software or emergence of software in networks gave a boost to a direction which is a software defined networks, which actually has a central control over the network, where you can where it can happen that it is actually separating the control plane and a data plane, and apply some rules over the network by that central location. So the futuristic services in the network, like massive IoTs and blockchain and metaverse, they are actually a latency sensitive applications services, and they also require their own bandwidth specifications. So the current data plane delivery method actually cannot satisfy the requirement because the services require the bandwidth allocation and latency requirement. They have different bandwidth requirement as well. So there is a need of method which can actually optimize the policy in the data plane data domain. Also it can determine the policies for the future services. For example, if some service has emerged, and then it can satisfy that service requirements as well. So it also there is also a need of best strategy to meet the demand of the future services. So actually the project I am working on is the goal of the project which is I am working on during my PhD is that we have to achieve and optimize open flow data plane delivery rules. So how actually we are going to achieve this by applying some deep learning methods to predict the traffic and to predict the traffic on the network, and also to apply some deep reinforcement learning methodologies to optimize the policies which can be apply on the network to satisfy the requirements of futuristic services, you can say. Our secondary objective of the project is that for future network services requirement, we need to improve and proactively apply the flow rules, delivery methods or rules on the network, also to achieve some optimal quality of experience and quality of service for the network. So there is this is the difference that the legacy SDN controller, how it actually works, and then how we are actually going to make it. The legacy SDN controller network relies on the topology discovery, which can be provided by the routing protocol, and there is a path computation. It provided into the routing information, and then it actually constructed the forwarding policies, and that policies are then applied to the network. So migrating from the legacy network, the next generation DRL driven network SDN controller, it actually discover the policy automatically by using the GNN. By taking the information about the routing and monitoring data, it actually discovers the policy. It actually discovers the topology, and then based on the data it is collected from the monitoring, it will decide the DRL based policy, some optimized policy, and this will be then forwarded to the forwarding policy, and the policies will be deployed over the network. So actually how we are doing it in project, we created a test bed which actually develop a next generation SDN based test bed. We are considering an ONS open networking operating system and OVS open virtual switches. We created this topology based on these OVS and ONS. We also collected the traffic data from the network, the topology which we have developed, data collected, and we then pre-process the data, and we analyze the data. Also we stored that data in a time series database, which is a Prometheus, and we use Grafana tool for the visualization of the data. So the type of data we are actually considering in our this problem is we are considering two type of data, which is a node function and a link function. A node function can be the top packet drop, and if packet drop and if CPU utilization, these kind of stuff, the packet process, these kinds of stuff. And the link function is like the functions of link, like latency and bandwidth. After that, we will apply some deep learning methods for network traffic prediction and network topology prediction, and from that deep learning prediction, we use that prediction to apply the deep reinforcement learning for policy, for making policy for operational state. And also the deep reinforcement learning actually based on the reward and penalty. If the policy goes well, then the agent of the deep reinforcement learning will get a reward. If it didn't goes well, then it will get some penalty. So this is actually the overall architecture. These are some there is some network, and we are collecting some metrics from the network in form of net flows and edge flows. These flows are then forwarding to Grafana and Prometheus. Prometheus is a time series database, and then Grafana is used for the visualization of the data, which is stored in Grafana, and then we can use Apache Spark for big data processing. It contains some machine learning models. We can use that as well, and we are also looking at if we can change and add some deep reinforcement learning as well in this. After that, the big data processing model will be the process data will be then used by the deep learning and deep reinforcement learning models, and it will be then the deep reinforcement learning output of policy formation has been given to is given to the policy formulation, and then the policy formulation part is then forward the policy to the SDN controller, and SDN controller deploy the policy over the network. So how this is actually how we are going we are doing it. So the current development in the project is about that we have actually made a test bed from the OVS. We deploy the Rio controller. Actually, we tried a lot of 5 to 6 controllers during our this deployment, but only the Rio controller because it is a configurable and programmable controller. So we select this controller for the deployment. Also, we use the open virtual switches and Prometheus and Grafana, and also we use some application like flow collectors at the watchtower. We have a watchtower which actually collects, and it contains the data. It contains the flow collectors, the data of the network. It has the Prometheus and Grafana for the storage and visualization. Here is the topology which is shown on the Rio controller. We currently we have utilized the 5 switches or 5 OVS switches, and this is the screenshot of the Prometheus we actually applied on that watchtower, and also we have visualized the captured data from the Prometheus. This is the Grafana dashboard basically of node exporter. So we tried to predict traffic by using the data we captured from our test bed for the traffic prediction, and we apply 4 actually models for LSTM and extreme graded boosting regressor, extra tree regressor, and random forest. Because of our generic data, because we have deployed a test bed, and then we apply video streaming scenario on that test bed, and we got the synthetic data from that. So that's why I think the LSTM is not performing well on our data, but we are looking some more techniques to get some more better results than these. Currently we have applied these 4 machine learning models. So for the conclusion, our project is basically spans on 2 years. So for the first year, we have utilized we have developed a test bed and implemented some data network data collectors. Also, we have some database, time series database. Also, we have a visualization of the data. Also, we utilize the network data for the traffic prediction. For the second year of our project, our goals are to predict the network topology by using the graph neural network. After that, we will be using the path prediction from a source to destination, and also we will be using the deep reinforcement learning agent, deep reinforcement learning model for the policy optimization. So that's all from my side. If you have any question, you can ask.
Okay, thank you, Amar. Thank you. So our next presentation is from again JU National University. Syed Saqib Jamal will present vehicular edge computing networks. He is a PhD student there. So Saqib, can you come, please?
Hello everyone, this is Sayyid Saqib Jamal and I'm representing Natural Convergence Lab on behalf of Jeju National University. So my topic for today is about an intent policy-based networking for identifying road accidents in vehicular networks. This is today's agenda that I'm going to discuss. First of all, we will talk about the software-defined networking and then IBN, intent-based networking. Then we will discuss about our application, the one that we are using in this project. And then we will be discussing about some of the scenarios that we can actually work on by using SDN controller with IBN. First of all, we must know what software-defined networking is and why we are using it in this project. Basically, when we talk about the ad hoc networks, because vehicular networks are all about the ad hoc networks, so it gathers a lot of data, so it requires the scalable controller to control the whole network. So for that case, that's why we are using the SDN approach and just for the testing and implementing new innovative ideas. Then again, for this case, for the ad hoc networks, we again need the continuous automation that we can also achieve using programmatically efficient network configuration that is also achieved using the help of SDN approach. Then we can improve the network performance and monitoring in a centralized control way. Okay, then if we talk about the intent-based networking, what intent-based networking is and why we are actually using it with the SDN controller in our project. Basically, whenever we, like as I discussed about the ad hoc network, so it should be completely autonomous in this case, like since the user provides the intent, it should automatically fulfills the purpose of the intent in its case at the end. So for that case, we require a lot of machine learning algorithms. And when we talk about the first point, it's like uptime point. Uptime point is basically the point that is mostly required for the ad hoc networks when we are actually required the low latency in this case. And in this case, because we cannot think about any other case, the most important thing is the low latency in this way. Okay, when we talk about the specific goals, the one that we are actually basically we want to make our network controlled without any human intervention, and it should be for when we talk about the intent based networking, we talk about the policies. So for that case, we are actually using the SDN controller to translate the policies in this case. And when we talk about the software use artificial intelligence to automate administrative tasks, we talk about the machine learning in itself that can make a network automated by using the closed loop. Okay, when we talk about the IBN with SDN controller, it creates all the self-managing networks. Whenever we talk about self-managing networks, this is the best combination to use it, IBN with the SDN controller. Then we can also can be familiar with the changing network conditions, automatically optimize outcomes without requiring engineers to touch the network in this case. When we talk about the IBN life cycle, it's like it starts from the intent and it goes until the intent is assured throughout the network. So in this case, what we actually do, we first provide the intent, it then translate, then we plan accordingly what we are actually going to focus and then accordingly from that policies that are being translated by the SDN controller, we configure our network, and then it continuously monitor, and we then analyze and validate using the machine learning algorithms. And after that, when we get the result, it gives us the abstract, like the story and the report, like whether the particular incident has been fulfilled by this particular network or not. So in this way, we can actually fulfill the criteria of the fulfillment and the assurance. So why we use IBN with SDN controller in this way? Basically, SDN controller translate the high-level network intent into low-level intent network configuration, and it can IBN system communicates the network intent to the SDN controller, and it also like translate the policies. Basically, we can give the example if the network is intent is to prioritize voice traffic over the other types of traffic, the IBN system will communicate with this intent to the SDN controller, and SDN controller then translate it into the policies to configure our network. Okay, why to use SDN in the Internet of Vehicles application? Basically, when we talk about the like using IBN approach with the SDN controller, we talk about the automation. And in this case, the first thing that comes is like the whole thing should be automated. So we basically deploy our IBN, which is an application on SDN controller, and we can use any kind of controller in this case. But for our case, like because it's based on ad hoc networks and the data set that we actually gathered, we use the APIs of the ONUS network controller that is directly integrated with our application. So if we talk about the vehicular network, how can we actually communicate our like the whole scenario with this particular terms? It's like the combination of IBN manager with the SDN controller that can be directly used with the RSUs, and these are the vehicles that that also have the communication in between. And if we like if we want to further elaborate our scenario, this can be our one of the scenario where we actually provide intent, and then it is translated by the SDN controller. The policies are being translated by the SDN controller. If we talk about our scenario is about the traffic system. So for that case, we need the safety applications that mostly requires a low latency in its case. Basically, here we can also focus the security part, but the idea is this IBN can be customized in itself. Like it can be used for either security or for the traffic sensitive applications. Our criteria is the traffic application. So for that case, we are focusing on low latency. So basically, this is the scenario where we can see if there is an accident, we can use the other vehicles as a gateway to highlight the incident, and then it can further provide you with all the things like whether there is an accident, and then you can change your route accordingly with this particular incident. For this case, for the data collection, we are basically using the Sumo OMNet, WEANS, and INET framework. OMNet is basically used for the network simulation, and Sumo is basically used for the traffic simulation. And we are using WEANS, which is particularly used for the like IOVs. And this is a framework that can be used where we can give some of the cars as a host, and we can simulate on this particular application, and we can gather our and dump our data set in this way. So basically for this case, we are using the .ini file is used to initialize the network. Basically, this is the initialization file that has the configuration of the host used in the network. And then there is NAD file. NAD file is basically language that I mean it is programmed on C language. That is basically the network description we provide by ourselves, like what area to be chosen, what range to be chosen. Like if the vehicle comes on this range, it can be detected automatically by our network, and it can our network can send the request whether to actually connect with our network or not. So if it accepts our request, it will definitely send the like it will send the reply whether it wants to join our network or not. So basically all these files are set up on OMNet++ for routing, and WEANS for vehicles as a host, and Sumo is used for traffic simulation. So basically, for in the conclusion, our goal is like OMNet. We use OMNet++, Sumo, WEANS on INET framework to create the dataset, and IBN Manager to provide the for providing the intent. For monitoring, basically there are so many tools that can be used for the monitoring, but here we can use the short range protocols, because we talk about the ad hoc networks. So this can be the good option in this case. And when we talk about definitely the IBN, so we talk about the closed loops, and the machine learning algorithms are needs to analyze the condition of the network and validate until it provides assurance on the purpose of the intent. Then we control. Then we use the SDN controller translates high-level intent, and IBN then deploys on SDN controller to automatically configure the network on a particular intent. Data set is used for machine learning algorithms to make the prediction on continuous change of topology. Our data is scalable. That's why we will be using ONUS controller in this case, because ONUS controller has API to directly connect with this like OMNet, and we can easily grab our data on that and easily work on that in this case. So thank you so much from my side. If you have any questions, you can ask me.
So is there any question? Yeah. Okay. My question is about the real-time connectivity of vehicles. So you said that the vehicle network is already established. So what if a new vehicle wants to join? Can it join in real time, or does it take a lot of time for it to join to the network?
Yes, that's a very good question. Actually, vehicle can join on real-time basis. Basically, if we provide some sort of security in our network, then definitely, as I was discussing about this diagram before, this one. Basically, ECC here is the elliptic curve cryptography. This is basically used for the security purpose. What happens actually, DMV is basically an organization that has all the vehicles registered in it. So it has the number, it provides the keys in this way. So what it does, it using ECC, it gives the access to the vehicles in this way. And if we don't consider the security part in our case, then definitely the request is to be sent by the network to the host, whether he wants to join or not. If it wants to join, it will send the reply, yes, I want to join this network. So in this case, this can be the case.
Thank you, Sagib. Thank you. So next is our final presentation from ICT Cambodia, and it will be by Dr. Rotna PhD. Sorry, the time was 5 p.m., but we have many presentations in this session, so.
Thank you. Good evening. My name is Rotna. I'm from Cambodia, and I'm from with my colleague. Actually, my topic is a little bit different from the one in network, but I hope it's related in some ways. Because Cambodia is an agricultural country, so we hope to leverage technology, especially communication, information communication technology, to help farmers. And especially we want to focus on the application in smart agriculture. I think this day we heard a lot of things about Internet of Things, Internet of Vehicle, and we have Internet of Energy. So I think many things happen. Okay. So because TEIN project is one project that come late to my school. Actually, I have one fund that support to build a lab we call Fab Lab at ITC. So TEIN project is a part that we can have some equipment in addition to my Fab Lab at ITC. And this is a thing that I'm going to present, maybe some platform that I'm focusing on the IoT and some testing parameter that is basic for electronic and the application IoT in smart irrigation and some smart controller and a lot of smart system that apply to one thing we call Yamato Farm. That is a Japanese company that come to Cambodia and they make a big farm to support some product to Japan. And lastly, we have the Internet of Energy, just briefly to talk about this, because we have a one collaboration with a Hong Kong company. So the idea of our Fab Lab is that we have the Fab Lab Center that is in ITC. So we want to generate the idea and we want to make community, to prototype testing, to research and develop the IoT product to our consumer. But we are not commercialization, just only develop the product in terms of prototyping. And we want to collaborate with the industry in Cambodia, especially the stakeholders that are related to the farm. And we have collaboration space, research and development, and fabrication space. There is only in-house, it's not very big. And this is the flow that we are going to do. We have our community and we have our meeting before we finalize, and we have talked to the consumer, and then we have a feedback and we discuss until our prototyping is successful. So this is our lab facility. We have 3 compartments, and I think because of TEIN project, we will enlarge our lab into a network lab. So we have some equipment from the TEIN project, and we have some our equipment that are high computing power PC. So right now we have a measurement and diagnosis section for electronic, and we have workshop that we have 3D printer, and we have some PCB fabrication and also assembly. So these three compartments will support our activity. So I think from here maybe it has some relation to the network that this workshop has been conducted. So we have developed our sensor node here, and we want our sensor node to connect to the network through a gateway, and then the sensor node should be receive or send some data to the network or receive some command from the end user. So hopefully this sensor node can communicate with the end user through some platform of communication. So firstly, we develop a multi-test parameter. So you can test some parameter in the farm application. For example, humidity, temperature, moisture, soil temperature, or pH level. So this device does not have any connectivity to the network, actually. So it's a handheld device. But what happens if this device can be communicated to the network? So this is our prototyping under the name of HIP. That is a big fund in our country. So we developed this prototype product, and this is the logo of our Fab Lab. But now we haven't changed because it violates the idea or the privacy of the other. So the controller that we are applying is first we apply in a small greenhouse that we grow vegetable, and we try to deploy 2 sensor nodes, and we try to communicate with the network. So we have the controller here that can communicate with the internet, okay, and we deploy our sensor node on the ground, okay. So we can control the temperature, we can spray the water. So the block diagram, we have 2 sensor nodes, just a test. So we deploy sensor node 1 and 2, and it can communicate. It has a Zigbee module that communicate with the network, and this is the controller that communicate with the gateway and communicate to the internet. So if the soil is dry, so the sensor node will send the data to the controller, and then if the soil is dry, so the controller will monitor and will control the pump to regulate the water to drip. So this is the data that we record, and I think because now we don't have the platform for storage the data, they use the open source we call ThinkSpeak, so they can record the data from the sensor. And another one we call another product, which is we call EPS32 based smart controller. The reason we call EPS because we use the system on chip EPS that has been fabricated by the company, and we bought that and we developed based on that system on chip. It has a Wi-Fi module in there, so we want to generalize it. We does not mention to a specific application, so we generalize to control anything that we can communicate, but we perform only 3 tasks. First, we call scheduling, automatic, and manual mode. And this is the display. This is a Cambodian character, actually. It's a little bit difficult to read compared to English, but we want to have our own language. So we put in here our display. But this product is under tested, so it's not finalized yet. Our team is working on that. And this is the hardware that has been tested, fabricated and tested. Actually, because in Cambodia, in my lab, we don't have a full functionality to fabricate the PCB. So we send to China, and then we assemble in Cambodia. Okay, because China have everything. It can fabricate easily. But later, because we don't want to do that, because if we do that, our bot they will know everything. Okay, so this is the data has been recorded, and we have another collaboration with Yamato Green, because a big company in Cambodia. They want us to replace here. They call CAN bus. It's a communication interface that used in the car, but it's not convenient. So they want us to use a wireless. It's very challenging to communicate with all sensor node to the internet using this wireless, because it's in a very, very remote area. It's not we cannot use cellular system. So we need a special connection. And this is the last of my presentation. It is the Internet of Energy. This word is not made by me. I think maybe it's a little bit confusing sometimes. But we work with Solar Geo. This company make some product for the application in electricity, and they basically focus on the solar farm. In here, the reason they call Internet of Energy because information communication is very, very penetrate to every field. So the infrastructure of electricity need to be upgraded, need to be more automated. So by leveraging this information technology, so we can leverage the infrastructure of electricity, and then we call Internet of Energy. Thank you.
Thank you, Dr. Peck. Are there any questions? Yeah. Okay.
Actually, it would be not related to directly to your presentation, but that is my question. Actually, if we expand the project to the next step, then I just wanted to make some application for the IBN system. Then some application can be developed like you. Then that software should be developed as the microservices. Then I guess you can develop some module stay in the edge systems, and then some module can stay in the central cloud. Then according to the demand, those some module can be moved to the another edges, and then it can be located in the several cloud system. Then I think if you can develop it as the microservice platform, microservice the mechanism, then it would be better. So I think the software part of the system would be rather simple, but the whole design could be made like that. Then I just want to know your intention or plan.
Thank you, Professor. Actually, in ITC, the word microservice it's new for me actually. So because in ITC mainly we focus on apply, not mostly apply to solve the problem in our society, especially in the farm, because the government put a lot of effort to make this farm to be more modernized. So from the perspective of our side, we have a technological engineer. We want to solve that problem, and our starting point here, because we hope that the IoT product could help them, and because we want to leverage this information communication technology, so we want to build that. But from the perspective of resource and knowledge to build that, we still have some problem, lack of that. If we want to build our own IoT platform, it's very difficult right now. For example, we use things we call ThinkSpeak. That is open source, because we cannot develop that by our own for the time being. Yeah. So from our perspective, we want to move to that way, but we move in a very difficult way because we move and learn. So we hope to achieve that. I hope this is what you. Yeah.
Develop it as the container-based application. Then the some container can reside in the edge system, and then some container can reside in the central cloud. And they can communicate and interact. Then I think actually the container migration can be applied to the system. Then according to the those framework, I think service function chaining could be applied to those kind of flows. So that is my intention. So if you can develop it as the container-based application, I think you can take those approaches.
It would be nice, Professor.
Like not physical devices, but virtualized
Virtualized.
containers or virtual machines. They wants to say this.
Yeah,
Because you've been working on the physical.
Yeah,
devices
physical
so
part.
far.
Yeah.
Yeah, the person wants to say that if you can put something like containerized environment and then try to communicate central cloud and edge using those containers. So you divide the services. You use some part edge cloud and use some part of the device. So you don't put everything at one place. It's like divide the work the complete system.
Okay. So I think that would be nice.
Yeah.
Maybe approach in that way. Yeah. Because at the beginning I don't have the the knowledge in here, so that's why I'm confused. Yeah. Yeah. Thank you, Professor.
I think we can move to that point, but maybe it take maybe a little bit time because I have some PhD student. They focus on something like cloud or SDN or VNF. That I think we can work together with the IT team. So to finalize or to find a way to merge together between application layer and physical layer. Yes. Thank you.
Okay, thank you, Dr. Beck, for your presentation. So with this, we end our session. Thank you all for attending the session. Thank you very much. Thank you.